Hi, good morning. Okay, today we are going to look at parallel lines and angle bisector. Okay, the first part is we are going to look at the parallel line. Now, the parallel line in locus it's defined like this: the locus of points that are of constant distance from a given straight line. Here, let's say I call it AB, is a pair of parallel lines. Okay, so this locus it must be equal distance. Okay, constant distance means equal distance from a given straight line. Okay, let's look at this example. Diagram shows a straight line AB. Can you see AB, right? Describe the locus of point K, which is 1 cm from the straight line AB, right? So this is straight line AB. You are supposed to draw a locus K which is 1 cm away from AB. Now the key point here is you must look for, if it's a parallel line, you will have equidistant or same distance from a line, a straight line AB or PQ or ST like that. Okay, so here it's AB. Now hence construct the locus of K. Now description, locus K is a parallel line 1 cm from AB. Now how to do it? Take a look at it, right? Take a look at it. Okay, let's say this is your parallel line. Okay, I'm giving you a little bit more difficult. The parallel line, the straight line is going down this way. The straight line is AB is going down this way. So let's construct a parallel line which is equidistant from AB. That is our locus K. I've already done for you. I'm going to show you how. What I'm going to show this side A will be the same for B, so I don't have to repeat at B. Okay, put your needle here, your compass, right? Your compass at point A and mark this one here and turn around and mark this side. You see this side, right? Now since there's no line here, you extend a line. Use your ruler, place it here, extend a dotted line. Why are we extending? So we will know where to place the needle. Here we know we can place a needle here. Now without the extension here, we don't know where to place the needle. You may put here or here, little bit above or below. So exactly you want to know. So this line will cross at this point. So you can place the needle there. So the next thing would be, right, you open up a bit more, you get this arc here. Can you see the arc here? This one, right, and below one. And bring it over to this side. You do the same thing. Place the needle at this point here, and this arc here, and this arc here. So you will see, can you see, a cross here and a cross here. So join these two cross and draw a line, and the line will pass through A, which is perpendicular to A or AB. Perpendicular means 90 degrees, right? Now you can use protractor to do, but this construction locus you don't use protractor. Most of the time you're supposed to use a compass with a ruler and pencil. So once you get this line, it's a straight line. The next thing, you can measure 1 cm, put a mark there, 1 cm below, put a mark there. So if you look at the number, first, number 1, you have to get these two arc. Number 2, from here you get this line, and from here this line and this line. Number 3, to construct this straight line. Okay, right. Now all this is not the locus yet. You do the same thing over here. These two cross, from here you get these two cross, join this one, okay, and then you measure 1 cm, put a mark there, 1 cm, put a mark there. So your locus is now joining this point here, which is 1 cm from A and 1 cm from B, and drawing the straight line. That's the last part. Okay, so drawing this one from here. So you have one set of parallel lines above and below the line AB, which is locus K. Can you understand? Right. Now question can be, example 2, take a look at it, little bit different. Diagram below is a straight line it's a triangle. Can you see triangle? A, B, C. This is a triangle, right? Now, a point Q moves such that it is always 3 cm from line AB. Now, when it's always 3 cm means equal distance from one line, a fixed line AB, then it is a parallel line. Please remember the key word is fixed distance from a line, not from 2 points or 1 point. Okay, just to recall, fixed distance from one point is a circle. Fixed distance from 2 points A and B means it's perpendicular bisector. If it's a fixed distance or constant distance from a line means it's a parallel line. So we are going to do the parallel line here. So since they have chosen this line, right, and your locus is equal distance from AB, what do? Same thing. Place your needle at point, let's say start from A, right? Put across here, put across here. Since this side is extended, so you extend the line until you get the cross here. Then place the needle here, you get this cut. Place the needle here, you get this cut. Join point A and this cross and draw a straight line. So this is 90 degrees to A. Do the same thing at point B, right? Place the needle here, give a cut here, extend the line so you know where to put your needle. From here, you get a cut. From here, give a cut. Join point B to this cross here and draw a straight line. Now once you get the straight line here and here, what is the distance? It's 3 cm. So what do? Use your ruler, measure from here 3 cm. It's a straight line, right? Put across there. And from A, you put across there. So this distance from here to here is 3, and also from here to here is 3. Join this point here and this point here and draw a straight line. The red line, can you see? Right. That is the locus Q. Now why did I put dotted line here outside? Because the locus is within the triangle. So the triangle is only this much. So nothing outside. So to show your construction line, don't go and erase this. Put a dotted line. Right. So the locus is from here to here. I name it as locus Q. Please label, don't forget. Right. Do you understand? Okay, this is how you do parallel lines. Now let's look at angle bisector. The same way, right? How do you know the locus is an angle bisector? Take a look at this definition. The locus of points that are equidistant, again equidistant means same distance, from two intersecting lines. So when I say equidistance from two intersecting lines, quickly your mind must go to angle bisector. That means the question is asking you to create angle bisector. So it's an angle bisector, or sometimes a pair of angle bisectors. So let's look at this one and this one. So this is one angle bisector where line AB and line BC joins at point B. Another clue is, if you are going to do angle bisector, look for one common point of two lines like AB and BC. B is the common point. So you're going to put the needle at B. Okay, so this is the common point. Put the needle at B, give a cut here and cut here. Right, you know, right? Put your needle at B, give a cut here and another cut here. Then bring the needle over at this point, right? Give a cut here, and from here, give a cut here. So you will get this cross. You join from point B to this cross and draw a line. So that's going to be, let's say if it's locus X, then it's locus X. So from point B, get these two arcs. Then these two crosses here, where you get this arc give you a cross, join these two, you get the locus. Now let's look at when you get two loci, two lines, right? When they cross over two lines, they don't stop here. Here they don't cross over, they stop at point B. But here, these two lines AB and CD, they cross each other. That means equidistant from here to here is 1, here to here, and here to here, and here to here. Confusing? Not really. So let's do the first one. Put your needle at point where they cross, right? Get this arc and this arc. Bring the needle over here. From here, get this arc. From here, get this arc. Then join this point here. Put a ruler this way. Draw a straight line. You got one locus Y already. Not enough. You can still do another one here. So from here, you can do this side or this side. So I did it this side. Put the needle here. Get this cross and this cross. Right? From here, get this cross. From here, get this cross. Put the ruler this way. Connect this cross here to this point and draw a straight line. Okay, done. Another locus Y. So in this here, you have one pair. That means two lines, locus lines. Both locus Y and locus Y. Can you see? Right. So there's a difference between this and this. Right. So the example, the same thing. Right. I have line L here and line M here. I'm supposed to get locus, construct locus X, which is equidistant from line L and line M. So we know it is crossing over this way and this way. Right? So what I do the same thing. This is the point of intersection. Put the needle here, get this cross and this cross, this arc and this arc, and from here you get a cross, draw this way. And then you can do this side or this side. So I'm doing this side. From here and here I get the cross, join this way. So locus X here, locus X here. Can you see? Very simple, right? So I have done all four loci in 2 dimensions. Yesterday we learned circle and arc of circle. So again I repeat, circle means one fixed point, right, and a constant distance from the fixed point. And then perpendicular bisector, 2 fixed points and equidistance from the 2 fixed points. The third one is parallel line. Parallel line means one line, a straight line, and your locus is equidistant from the parallel line, right? So it can be above and below. If it's a vertical line, then it's on the right and left. If it's within a given shape, you only do within the shape, right? Angle bisector, we have just looked at it, where the 2 lines meet. If there's only one point, right, so only one locus. If the line crossover, you get 2. Okay, can remember? Okay, your exam or the actual question will combine all these 2 or 3 elements. So when you read questions, you must understand whether they are asking for angle bisector or parallel line, or it's a circle or arc of a circle, or it's a perpendicular bisector. So do enough exercise and you will know. Not very difficult, right? Okay, enjoy the video and then answer the questions. Thank you.